video is about piecewise functions. A piecewise function is made up of at least two equations, each defined for a different part of the domain's function. So even though this looks like it's two different functions, it's part of the same function. It's called a piecewise function. The left part of it is going to look very different from the right part of it because they're defined by two different functions. So this function is 2x minus 1 for every value of x that's less than or equal to 1. And it's negative 3x plus 1, which is a totally different function, for every value of x that's greater than 1. I find that the easiest way to graph these is to make a table of values for each part of the piecewise function, and be very careful about the numbers that you're using for your inputs. So in the first part of this piecewise function, I'm only allowed to input values of x that are less than or equal to 1. So things like 1, 0, and negative 1. For the second part of the function, I can input anything greater than 1. I'm still going to start from 1, and you'll see why when I put this on the graph, because I could include things like 1.2 or 1.3, right? But I don't want to plug those into my table, so I'm going to start with the number 1, and then I'm going to include things that are greater than it, like 2 and 3, okay? When I plug in the 1, 0, and negative 1 for my first table, I'm plugging it into the first part of this piecewise function. So plug in a 1 to that, and you get 1. Plug in a 0, and you get negative 1. Plug in a negative 1, you get negative 3. For the second part of the function, I'm plugging in the inputs 1, 2, and 3 into the second part of this function, the negative 3x plus 1. Plug in a 1 and get negative 2. Plug in a 2 and get negative 5. Plug in a 3 and get negative 8. Okay, and now I'm ready to put these ordered pairs on the graph. I'll start with the left part here. 1, comma 1. I am allowed to include that point. 0, negative 1, and negative 1, negative 3. And when I connect these, I do not go past 1, 1. Now, it would continue down in this direction forever, so I can put an arrow in one direction, because that is the direction in which x is less than or equal to 1, so I can include that. The second part, the point 1, negative 2, is technically not included on this graph, right? Because it says here that I can only define this function for values of x that are greater than 1, and this value of x is actually at 1. So when I go to the point 1, negative 2, it's like I want to start just a little bit past it. So I'm going to go to the point 1, negative 2, and start that with an open circle. Okay? Actually, that should be really right on it. With an open circle. Can't seem to get right on it. Right on it with an open circle, and then plot the other points with closed circles, because they are included. So 2, negative 5, and 3, negative 8, which would be off the graph about down here. And when you connect these dots, just don't go through your open circle. Show that you're not actually including that point, you're starting right after it. And this is the graph of the piecewise function. It's like a Frankenstein graph. It's got an arm from this other function and an arm for this other function. They've been chopped up and put together on the same graph. To go the other way, you may have to write a piecewise function for the graph that you're showing. Okay, so I see that I have two functions put together here. Let's do the green one first. It's a linear equation. In order to write a linear equation, I want to use I want 2 points from the graph. So I see that there's a point here and a point here. This point looks to be at negative 3, negative 2, and this point is at 0, negative 3. So I'm going to write a linear function using those 2 points. The slope subtracts the y values, subtracts the x values, comes out to negative 1/3. So to write the equation of it, and since I'm already given the y-intercept, I can use slope-intercept form. The equation of the first part, I'll write it as y subscript 1, would be mx plus b, and the b is the y value of the intercept, so negative 3. So that's the first part. I'll switch to red to get the other equation. Remember that you need 2 points from the line to do a linear equation. So here's a point, looks like it's at 3, 4, and this point is at 0, 1. Start by finding the slope, subtract the y values over, subtract the x values. The slope comes out to 3 over 3, which is 1. Again, I have the y-intercept, so I'm going to use slope-intercept form. So y2 is going to be positive 1x plus the y-intercept, which is 1. And now I'm ready to put this together and write it as a piecewise function. So for a piecewise function, you want to define f of x, put one of these brackets so that you can put both functions in there. The first part of the function is negative 1/3 x minus 3 if x is, and then we've got to figure out what part of the graph is the green function defined for, and it appears to be defined for all values of x starting from 0 and going everywhere to the left. So for all values of x that are less than or equal to 0. Whereas the second part of the function, which is 1x plus 1, is defined for all values of x that are greater than 0, but it does not include 0 because that's where you see the open circle on the graph. And so this is the piecewise function that is shown here. You may also be asked to evaluate a piecewise function for the given values of x. So the piecewise function here is pretty complicated. It's got 3 pieces. One of them is defined for x values less than -3. One of them is defined for x values between -3 and 1, but not including 1. And then the last part is defined for x values that are greater than or equal to 1. So when you're asked to evaluate something like f of -5, just make sure you're plugging it into the right piece of the piecewise function. So for -5, it looks like I need to plug it into the first piece because that is defined for x values lower than -3. So I'm going to plug this into the first piece of the function, which just says 3x. So this equals -15. F of 0, figure out which piece of the function to use. It looks like I need to use the middle piece because that's defined for x values between -3 and 1. So plug in 0 into the middle part of this function. 4 times 0 is 0 minus 1 is -1. And for the last example, it says f of 4. Now I need to plug it into the last part of the function, which is a constant function. It says f of x equals -2. There isn't even anywhere for me to plug in an x value. F of 4 must equal -2. And that is all.